Okay, welcome back to this lesson. Now we're looking at something very shortly. Uh, Last lesson we were listing this set. I would like to make a quick correction. And we said minus 5 less than x less than 5. I was talking about open interval here, right? So this 5 is not inclusive, please. This 5 is not inclusive. And the reason is clear. I said that when you have open intervals, let me just list the intervals you have. You have open interval on both sides. Then you have one open, the other closed. Then you have one closed, the other open. Then you have both closed. So these are the four kinds of intervals you could have. In this listing, A and B would not be involved. I mean, in your listing, the boundaries will not be involved. In this listing, A will not be involved, but B will be involved. In this listing, A will be involved, but B will not be involved. In the final listing, A and B would be involved. So in this case, the example I gave, since I already analyzed the example to give us a particular answer, so just permits me to list 5 yet, but I will include this sign. All right, so less than or equals to 5. So please take note of that correction. All right, so let's go on with today's class. So let's look at this. So we said we'll continue with symmetric difference because there are two types of difference. Your difference could be, let me call it algebraic difference or basic difference, which is A minus B, which I defined as element found in A but not in B. We discussed that previously. Now, if you have symmetric difference denoted by this delta symbol, symmetric difference, what does that mean? Symmetric difference is denoted by delta symbol. In this case, what we just mean is you have the difference of A and B, then you take the union of the inverse difference. What I mean is you take the difference of two sets, take the union, and then change the orientation of the operation. So if you have A minus B initially, then you now have union B minus A. So this is the symmetric difference of two sets, and I believe you can handle this. That's that about that. All right. Now let's look at, then you should also try this. Check this out to see if it is correct as your form of DIY. Okay, do this yourself. So check if the symmetric difference is commutative. So check that and reply in the comment section if you have done that yourself. So A delta B, is it equals to B delta A? Let's say this is option A, and option B is A delta B, okay, not equals to B delta A. So check this, see which option is correct. Is A or B correct? All right, so let's see if you are following. Right, now let's look at something else. Before we look at Venn diagrams, let's quickly look at another operation called the cross product. Called the Cartesian product. Sorry about that. Cartesian product. I'm already in the vector world. We'll get there soon. Alright, that will be QBM 201. So Cartesian product, what do we do here? It is denoted by the symbol X, like your regular times cross product, okay? Like your regular multiplication sign. Alright, so why is it called Cartesian product? Why Cartesian? We know what product means, multiplication. But what does this Cartesian really mean? Now, you remember from your geometry, your basic geometry, there's something called Cartesian plane. Is that correct? Or Cartesian coordinates, where you have your y as your vertical and your x as your horizontal, which you call abscissa and ordinate. Okay, so if I'm going to write any location in this space, say 1, 2, we all agree that this is like saying x, y. So from the idea of this written pair is why we have Cartesian product. So it means that we are multiplying with respect to the arrangement and the orientation, and we are putting our multiplication in pairs, these Cartesian pairs like x, y. So you will see very shortly. Let me quickly give an example to pinpoint the idea. All right, so if I have a set A, for example, given set A, I'm not going to define it easily again. So I'm going to give us a definition that is standard, advanced standard. All right, so look at this definition. Let's say I have A comma B, okay, and then I have a set B that is equals to x, such that x squared minus 1 equals to 0, and x is an element of say z negative. Yes, look at this. Look at this. So so for me to now evaluate A cross B, which I believe you definitely know that this operation will not be commutative. A cross B cannot be equal to B cross A. You will see shortly because the arrangement matters. All right. So how do we evaluate A cross B? For us to evaluate A cross B, we need to know what A is and what B is as well. So what will be A? A is already A comma B. That one is simple. It's already defined easily. So for us to define set B, what do we do? Let's read it. It says x is such that x squared minus 1 is 0. So you have to first solve this equation. Now for me to solve this equation, it means that I will have x squared minus 1 is 0. If you don't know how to solve this equation, you should visit my videos on equations, okay, to guide you. It's the videos on mastering algebra, basic algebra. So it will guide you to know how to solve a quadratic equation where the coefficient of x is 0. I'm sure you will understand better when you check that video. So x squared minus 1 equals to 0, right? And this is difference of 2 squared. This is x plus 1, x minus 1 equals to 0. And so this means that x is either 1, minus 1, or 1, okay? Now, if I'm going to now define b again says that my x that I've listed from this equation must be an element of negative integers. Now this means that for me to have x to be an element of negative integers, I will look at the values of x I got, minus 1 and 1. You realize that 1 will be omitted, so minus 1 will be the only element of b, which will now make b a singleton, okay, or unit set. Alright, so to now find a times b, or a Cartesian product b, will be what? How do I pair it? Now since I have a and b in A, so this is where I'll pair it. I'll use the Cartesian pairs. Now we have a. If I begin with a, I will have a comma minus 1, pair it to what you have as b. Then I will have b again, pairing with what I have at b. So this is b, the Cartesian product of a and b. So I believe this is simple. A comma minus 1 comma b comma minus 1. Now you agree with me that this is definitely not the same as b, because if I change the orientation, b times a would be what? From the analysis, that means I will have minus 1 coming first times a, then minus 1. I mean minus 1 comma a and minus 1 comma b. So this will be my element. And you agree with me that this is saying x is a, y is minus 1. This one is saying x is minus 1 and y is a. So a times b is not equal to b times a at any. I don't believe at any point in time this would ever your Cartesian product ever be equal of different sets. So a times b is not equal to b times a, which means that your operation, your Cartesian product operation is not commutative. Okay, take note of that. It's not commutative. All right, so this idea will guide us to understanding what these things mean actually. Now let's quickly talk about the power of a set. Let's look at the power of a set. Now the power of a set is strongly dependent on our idea of cardinality. So if I want to find the cardinality of the power of a set, the power of a set basically is actually the total number of proper subsets that is in that set. Some people say improper, however it is just the total number of subsets. So your power is the total number, okay, total number of possible subsets in a given set. Total number of possible subsets in a given set. So now we can know the cardinality of the power of the set actually. Okay, so where the cardinality of the power of a set is actually equals to, is given by the equation 2 raised to the power n. Okay, where n is the number of elements in the set, is the number of elements in the set, okay, or the cardinality of the set actually, number of elements in the given set. Okay, so let's look at this very quickly. Imagine I have a set A which is equals to 1, 2, 3. How do I find the power of this set? Now I can already guess the number of elements I'll find in this set. How? My n of the power of the set, okay, will be equals to 2 raised to the power 3, which is what? 8. So I have 8 possible subsets in this given set. But if I want to actually list the power of this set, if I'm supposed to find the power of the set, that is P of A. What will be P of A? This is what we are saying. Now, what are the total possible subsets you could have? The first one you could have is a null set. You can have an empty set in this set. Empty set is the subset of actually every given set. So empty set is a subset of this set. Now you could have one as a set likewise. As a subset, sorry, you could have 2, you could have 3. Now you could have 1, 2, you could have 1, 3. You can see you could have 2, 3. Somebody is saying, so you're thinking in your mind you could have 3, 1. No, you can't have 3, 1. I told you repetition is not allowed in sets. So 1, 3 is the same thing as 3, 1. Take note that these are curly brackets and not Cartesian brackets. Okay, this is where the problem is. Now, so we could have, let's see if we have gotten to our 8. 1, 2, 3, 4, 5, 6, 7. There is still one more. What do you think the last one will be? Of course, you could have all of them all together. So this would be the power of set A. So the null set inclusive, each set, and then pairing the two sets in different forms, okay, where repetition is not allowed based on the orientation, and then the 3 sets all together. So the power of this set is the total number of possible subsets found in the set. Moving on, we could also have something called the order of a set. Okay, the order of a set. The order of a set actually is the same thing as the cardinality of a set. It just tells us the number of elements that we have in the set. Take note of that redefinition. Then also we have something called equality of a set. Let's look at the equality of a set. Now, when is a set said to be equal? Now I'm going to be giving us two distinct, or let me say this: they are quite similar, but they are not the same. They are quite similar, but they are not the same. Now, this is equality of a set and equivalence of a set. Now, two sets can be equivalent, but they might not be equal. So you see what that means. The equivalence of a set. Okay. Oh, sorry, equality of sets, not of a set. So equality of sets and equivalence of sets. Sorry about that. Equality of sets and equivalence of sets. So let's see what this means. Now, two sets A and B. If I have two sets A and B and I say that these two sets are equal, what does it mean? It simply means that the elements that are A are also found in B. So let's assume that X connotes all the elements in A and X and Y connotes all the elements in B. It means that X equals to Y. I believe you understand this. If X denotes all the elements in A and Y all the elements in B, it means that X equals to Y. So which means that for A and B to be equal, the only condition is that the elements in A can also be found in B. And one thing that is sure for the equality of a set is that if two sets are said to be equal, it simply means that their cardinalities are the same. Now let's look at the difference between equality and equivalence. Equality represented as equal to, equivalence represented as a 3 strike letter like that. So if I now have two sets to be equivalent to each other, now this simply means that their cardinalities alone are the same. So the cardinalities is what we use to define the equivalence of a set and not what is inside the set actually. I come again. Two sets are said to be equivalent if their cardinalities are equal. So we don't care what is in those sets. We only care about the number of elements in this set. So if I say set A equals to 1, 2, 3 and set B equals to 4, 5, 6. Now, set A and B are not equal. However, set A and B are equivalent. Now, what does this mean? If you look at set A, it has a cardinality of 3. Set B also has a cardinality of 3. But since they have the same cardinality, it means that they are equivalent. But then they are not equal since the element in A is not the element in B. I believe you understand that. Okay, so I come again. The quality of a set, or the quality of sets, of two sets of sets, where it can be A, it can be 3 sets, it can be 4 sets, as many as it may be. But the point is, if we have sets to be equal, their elements must be the same. And if their elements are the same, definitely their cardinalities would be the same. Now, it means that the cardinality condition, although found in both definitions, satisfies necessarily equivalence but do not satisfy necessarily equality. It is simply a secondary definition for equality, however a primary definition for equivalence. So the point is, primarily what defines the equivalence of a set is its cardinality. Primarily what defines the equality of two sets is the fact that they have the same elements. So elements, all right, elements for equality, cardinality for equivalence. So we can say that two sets can be said to be equivalent but not equal. But all equal sets are equivalent. Let's write that down. I mean, that looks like something we can put down. So all equal sets are actually equivalent. You agree with me, right? Because if a set is equal, it simply means that it is equivalent, since the cardinality will definitely be the same. So all equal sets are equivalent sets, but not all equivalent sets are equal sets. But not all equivalent sets are equal sets. But not all equivalent sets are equal sets. Okay. Now let's move on. I take that again. Okay, so that can sink in into us. All equal sets are equivalent sets, but not all equivalent sets are equal sets. All equal sets are equivalent sets, but not all equivalent sets are equal sets. Okay, take note of that, please. Now let's move on. Let's look at some interesting questions. Okay, let's look at this example. Now we're not going to do much questions in all of these teachings or lessons, because there will be a particular long video that will be posted on at the end of every lesson, that would cover all the topics and will cover all the questions on all what we have discussed. Okay, so it will be a long video where we'll solve questions together, so that we manage the time we have for just teaching only. All right, but it's good that we at least know one or two questions. I'll do one or two questions at least. Now look at this question. I want to give us something that we would be able to analyze within a short time. Okay, something we'll be able to analyze within a short time. Now look at this. Let's see, right? So let U be the set of integers. Let U be the set of integers. Look at this example. Let U be the set of integers, all right, such that one is less than x, okay, and less than or equals to 100. So we are asked to now determine, the cardinality n of C, okay, where C is the set of integers in U, the set of integers in U, all right, that are not divisible by 2. And look at this question. Yes, this question is quite heavy, coming on someone who is just learning set for the first time, but I think it's good to solve the tough questions as examples sometimes, rather than the conventional way most of our teachers and lecturers do, solve simple questions and give difficult exams, right? So let's see what's going on here. Now let U be the set of integers such that 1 is less than x less than. So this is a closed interval, a completely closed interval. So if I'm going to list my universal set, it means that we are saying 1, 2, 3 up until 97, 98, 99 and 100. So this is the set U. Now we have to determine the cardinality n of C where C is the set of integers in U that are not divisible by 2, right? That's what they ask us to do. So since we know our set U, and we have to just determine cardinality C, where C is the set of integers in U that are not divisible by 2. Now, the best way to solve this is first to know the set C prime. Okay, let's look at the set C prime, that is the set that are in U but are divisible by 2. Do we understand that? If C is a set of integers that are in U that are divisible by 2, do you agree that set C prime would be the set in U, right, that are divisible by 2? Do you understand that? Okay, if you don't understand that, let's do it this way. Instead of saying C prime, let's just pick a, let's say E, let's say set E. Let set E be the element in U. Alright, let's set E, let me say this. Okay, so let's set E be the set of integers, okay, the set of integers in U, that are divisible by 2. Now this is easy, right? Now if we can do this, then you just subtract the total number you have here minus those that are divisible by U. That will simply give us the ones that are not divisible by U. And take note, the cardinality of n of U here, I believe we know that, right? You know the n of U here. Since you have 100 elements, 1, 2, 3, up until 100, that means that 100 will be the cardinality of your universal set, right? Okay. Now let's see how to find the set of integers. That is, let's find n of E. So you will now know that n of E will simply be, n of C will simply be equals to n of U minus n of E. I believe you understand that, since n of C are the integers in U that are not divisible by 2, and n of E are the integers in U that are divisible by 2. And that is just quite basic. Alright, so let's see. To find the integers that are divisible by 2, you agree with me that the first one would be 2, right? The next one will be 4, next one will be 6, right? And so on and so forth. Now for us to now find, we can't be doing it to 100. That would be quite tedious, but I think it is easy to find. How? You could just simply, since the last term will be 100 and the first term will be 2, so to find the number of E is just to divide 100 by 2, and that will give us 50. So actually there are 50 set of integers that are in U that are divisible by 2. Now if you don't agree, let's use sequence and series, which we've not discussed. We are here to discuss that in our lesson, but let's quickly use sequence and series. I believe that you might have known sequence somehow from secondary school, because I believe I'm speaking to advanced students, advanced mathematics students. Okay, so let's look at this. I want to believe that this would be an AP, an arithmetic sequence or arithmetic progression, however way you know it to be. Sorry, UN, not SN. Where your first term is 2, right? Since the element of E or the set E is actually 2, 4, 6, and so on up until 100. Okay, let me say 98, 100. These are the set of integers in U that are actually divisible by 2. So the first element will be 2, right? The number of elements, how many will you have here? How many do you think you have here? This will be 2, 4, 6. That means that ordinarily we had 100, right? And if you divide it by 2, that means you have 50. So n will be 50. Do we understand what I just did there? 1, 2, 3, 4, 5. If I fill up these spaces for U is 100. Now if I remove 1, 1, 1, 1, 1 from each one of them, it simply means that my n would be, or let's do it this way. Sorry, because n is what we are looking for. Okay, but I want to use arithmetic sequence to define it for us. So n is what we are looking for, the number of elements in this set. So a is 2. What will be the common difference? The common difference is the first term minus the second term minus first term, third term minus second term, and so on and so forth. The one after minus the one preceding. So this will be 4 minus 2 or 6 minus 4, which pinpoints that it is an arithmetic sequence. So 2 would be the common difference. What else do we need? We need UN. Don't forget that UN is the last term of the progression or the sequence, and the last term is 100. So let's find n. 100 will be equals to 2 plus n minus 1 d 2. So this will be 98 equals to, 100 minus 2, 98 equals to n minus 1 into 2, right? And this implies that your n minus 1 will be equals to 98 over 2, okay? Your n minus 1 now will be equals to 98 over 2 is 46. Is that so? No, sorry, 49. Sorry, 49. Because yes, 49. And your n will be equals to 1 plus 49, which is 50. So you agree with me that there are actually 50 elements, okay? So our answer is 50. So if you don't understand 100 over 2, you can go through the sequence way. Either way, we have 50 set of integers in U that are divisible by 2. So finally, to solve this question, n of c will now be equals to, what is n of u? N of u is 100 minus 50, okay? So this question is actually very simple. So the answer is 50. So there are 50 set of integers in U that are not divisible by 2. Now this is simple. Let me give us an exercise, okay? Let me give us an exercise. So try this yourself and let me see your answer in the comment section. All right, DIY. Now the same question. The only difference is, let's assume that your universal set is defined as x, such that x is an element of natural numbers, and of course is denoted from 0x, 0 less than x less than 300. Try this yourself, and then find n of c, where c equals to y, such that y is an element of okay, let me not use this, let me use words, okay? So where c are set of integers that are not divisible by 3. Try this. That are not divisible by 3. Okay, so let's move on. Well, the time is getting fast spent here, so I don't want to bore us too much with this lesson. So I'll close with introduction to Venn diagrams. Okay, so I'll introduce Venn diagrams, then we'll go full blown in the next lesson. So everything we've discussed so far can be represented diagrammatically, okay? So if I say set A, I can just say set A in a given space this way, A, and I decide to shade A, where the shaded portion is our solution. Alright, so if I say set A union B, in a case where I have A and B that are mutually inclusive, okay, I will have something like this, A, B. So if I want to I want A, I don't want to shade A union B. What I mean is, if we have set A alone, how do we shade set A? So the entire A is shaded this way. So can you see that even in their intersection, I'm still shading A, because A is actually this circle here. Can you see it? Although it enters B, does not matter. I just want to shade A. So alright, so we'll continue from here next lesson. Now, but before we do, if you have learned anything, please do well to share what you've learned in the comment section and subscribe for more videos, and to know, and also hit the notification bell to know when the next video drops. Thank you. Quite basic math.